When it comes to target 7-3, cross cancellation, and limiters, I want to let you in on a special situation, and it may affect you on your final. Hint, hint. All right, if you're so lucky as to get this question on the final. So I want to talk about. Okay. This looks very similar to the reaction that you have in your practice sheet. However, with a notable difference. This has two here. Two aluminums plus the gold chloride. And you can see across the way that I have changed that species in order to make it balance. I think that, ignore the other side. Two aluminums. All right, let's just say that's what it is. All right, my point is not that I just made this pretend reaction up anyway. What I want to emphasize is what happens if you put a 2 there. Now the one you have on your practice sheet has a 1 there, but I would be remiss if I didn't remind you that there are such things as mole ratios, and we run into the mole ratio issue when you're doing your titrations. So you have seen mole ratios before, but what happens if you have a non-1-to-1 ratio up here, such as 1-to-2? I want to show you how this might trick you. So what I did is I went ahead and I solved for this the standard way, using cross cancellation. All right. So suppose we had 3 grams of aluminum and 20 grams of gold chloride, and we want to figure out which is the limiter. And we have learned that you can't just look at the numbers here, because these are in grams, which are masses of particles, and grams does not take into account how big the particles are. You have to know how big they are and how much how heavy they are. So just because you have a bigger number here does not mean this is in excess, because these could be really huge particles, and 20 grams just isn't that many of them. So this could actually be the limiter. And the same thing here, just because you have 3 grams of aluminum doesn't mean that it's the limiter, because aluminum particles could be so tiny that 3 grams is oogles of them, and you have more than enough. So just looking at the grams isn't good enough. You got to look at moles, because moles actually is the number of particles. And to do that, we're doing our mole calculation using the cross cancellation technique. So 3 grams of aluminum over 1 times, I need those grams aluminum to cancel, so I put grams aluminum down here. I want to get into moles, so I put that on top. And remember, they're arranged diagonally because things cancel diagonally. And so if you go ahead and do this calculation, you will get 0.11 moles of aluminum and some change. All right, down here, same computation, but with the aluminum chloride. If you used 20 grams of aluminum chloride and put the molar mass there so that these cancel, then you will end up with moles gold chloride. And this is how many moles it is, 0.065 moles. So at this point, you would probably go, oh, hey, that's the lower number of particles. And because 0.065 is lower than 0.11, therefore this is the limiter. And I want you to put your brakes on that, because now that you're aware of the mole ratio issue, we need to look back up at the equation and see, according to the recipe up here, 2 moles of aluminum react with 1 mole of gold chloride. So that means that these need to be adjusted based on that ratio. Here's how you do it. Look for the number 1. Okay, we just need 1 mole of this, and we calculated 1 mole of that, 0.065. Now, in order for this reaction to work properly, you need twice as many moles of aluminum as you need of the gold chloride. So for this to work correctly, we would need twice 0.065. So let's see, that's 13.13. So this reacts with 0.13 moles of aluminum. They are in a 2-to-1 ratio. So notice what I did is I looked at how much I had that was with 1 mole, and then I said, okay, well, according to the recipe, I need double the number of moles as this, because 2 is twice as much as 1. And so for this to work exactly as written, you would need twice as many as 0.065, which would be 0.13. The problem is that the actual amount we have is less than 0.13. So we do not have twice as much aluminum as we have gold chloride. And therefore, we have 0.11. 0.11 is less than 0.13. So we do not have enough aluminum. Aluminum is the limiter. Because it has to be in a 1-to-2 ratio. And therefore, that's how you take in that 2 into account. Let's do another one to emphasize the point. Let's go back. Let's just pretend we were working with a reaction that had a 3 there. So they were in a 1-to-3 ratio. You would go ahead and calculate your values for just 1 mole. This is as if it was a 1-to-1 ratio, and this is what it would be. Then find the one that is 1 mole, and think about how much of the other species you would need if the reaction was to work correctly at that ratio. And so at that ratio, we would need 3 times this. And so that would be 19.5, 0.19, that would be 0.195. So on a 3-to-1 ratio, for these to react as written, you would need 3 times the amount of aluminum as you have of your gold chloride. And all right, if you have less than 3 times, then this doesn't have enough, and this becomes the limiter. And anyway, we have 0.11. 0.11 is way less than 0.19, so this would be the limiter in that case as well.